Okay, today we're talking about composition of functions. So let's see, given two functions, f and g, the composite function f, that symbol means composed with g, is defined by f composed with g of x as f of g of x. This is kind of the old school way of writing it, and you might see that on a standardized test or in the book. This is the new way of writing function notation. We just write f of g of x. Think of it like there's an inside function, g of x, which is cocooned inside of the bigger function, f of x. So it's a function within a function. So this is not multiplication. In fact, oftentimes students see f of x and they think, oh, f multiplied by x. Actually, it's just f of x. It's a thing. It's the name of the function. F is the name of the function, and we usually plug x into that. So let's say these are the two functions that we've been given. And so the first thing you might want to do is make sure you write this appropriately. So f composed with g of 3 is the same thing as f of g of 3. And so think of this as a two-step problem. First step is we're going to replace g of 3 with whatever that is equal to. So in this case, g of 3 is what happens when I plug into the g function. I'm going to plug 3 in there for x, because 3 g of x, g of 3. So 3 plus 1 is 4. So g of 3 is 4, because 3 plus 1 is 4. Now, that's my halfway answer, but it's not my all the way answer. So I've done the inside portion. Now I need to do the outside portion. So f of x, f of 4. So now everywhere there's an x in f, I'm going to plug in a 4. So this would be 4 squared. Plug in with parentheses, and you get 16. So f of g, this is how we notate our answer of 3. That is, you don't multiply that. That is our answer. F of g of 3 is equal to 16. The two parts. So you do the inside function, then the outside function. So here, let's write it this way. So we're doing it in reverse order, g of f of 3. So now f is the inside function. So let's do that. Everywhere there's an x in f, I'm going to plug in a 3 here. So this is going to be equal to g of, I like to see this step too, g of, and now we're going to plug in 3 for x right here. So it's going to be 3 squared, which is 9. So that's my halfway answer. Now I'm plugging that g of 9 into this x, right? So 9 gets plugged in there. 9 plus 1 is 10. And so the answer g of f of 3 is equal to 10. So just a two-part. Evaluate the first inside function, find that number, and replace it, and evaluate the outside function. Let's try it one more time. Let's try it with this one. So different functions, so the functions have changed. So let's do this one. So f of g of 2. The inside function would be g of 2. Everywhere there's a g, you're going to plug in 2 here. So this would be f of, see, g of 2 is 2 plus 3, which is 5. Now the 5 gets plugged into the x right there because it's x squared minus 1 is the f function. So this will be 5 squared minus 1, which is 24. This one would be g of f of 2. Let's do the inside function. F of 2 would be plugging in right there. So that would be, let's see, g of f of 2 is 4 minus 1, which is 3. Now I'm plugging that into the g function. So 3 plus 3 is 6. New problem for these. Plug in these numbers. So this will be g of negative 1. So the inside, this is kind of interesting. So you're plugging in the same function twice. So g of negative 1 is negative 1 plus 2, which is, let's see, negative 1 plus 2 is 1. That's the halfway answer. Now plug that answer into g again. So 1 plus 2 is 3, so we get 3. This one, f of negative 1, the inside part is, f of negative 1 would be negative 1 squared, which is positive 1. Plug that into the f function again, so 1 squared is 1. And now we're just doing this with, it doesn't look like we're plugging in anything into here. So it's understood, when you see this, it means the same thing as f of g of x. We don't know what to plug in, so we're plugging in x. And that's very common to plug in an x for something like this. So let's look at the inside portion here. And this is, you have to think of this almost like substitution, or you could think of it as plugging x in everywhere there's an x in the g function. So if you plug in, instead of x, we're going to plug in an x. Well, you get x plus 2, right? Or some students think of this as g of x is equal to this. I'm going to substitute g of x with x plus 2. Another way of thinking about this. So x plus 2. And so now we have to plug x plus 2. Everywhere there's an x in this function, we're going to plug in an x plus 2. So instead of x squared, it's going to be x plus 2 squared, which is a binomial squared, which means we have to FOIL that. So x squared plus 2x is plus 4x plus 4. I didn't show my work, but I FOILed it. And I combined inside, outside, 2x plus 2x is 4x. So that is the answer. And it's okay that the answer has x's in there because that's what we're plugging in, right? So g of f of x. So the inside part is f of x, that's x squared. So g of x squared. Everywhere there's an x right there, you're going to plug in an x squared. So this will be x squared plus 2. And you got it. And finally, two new functions here. So this is going to be g of x, g of x. So g of x is x plus 2, so this is going to be g of x plus 2. If I plug that in for x, everywhere there's an x, I'm going to plug in x plus 2. So I get, with parentheses, x plus 2, which is x plus 4. F of x. Let's do the inside part first. So that's f of x is x squared. So I'm just going to plug that in. Everywhere there's an x, I'm going to plug in x squared. So that would be, instead of x squared, it's going to be x squared squared, which is x to the 4th. And that is the lesson. Let's go ahead and, since we have a little bit of extra time here, because that lesson went really fast. Try to make sure you can see this. Okay, so which of the following is appropriately modeled with the equation y equals a x to the b, where a is positive and b is negative? So one way of thinking this through, let's just choose a positive number for a, like let's say that's equal to 2, and b is negative. Let's make that equal to negative 2, I guess. So this would be y equals a is 2, b is times x to the power of negative 2. So this is another way of looking at this. Really, this is 2 over x squared, right? So it's going to be undefined at 0. You could plug in some values here and see if it's, what happens as x gets bigger. So when x gets bigger, the denominator is a denominator. So like 2 over, say x is 10, that's 2 over 100. If x is 100, then that'd be 2 over, 10,000. It's getting smaller and smaller as x. So the pattern seems to be, boy, it's definitely not growing, right? As x gets bigger, it's getting smaller. And let's see, does it look linear? It doesn't really look linear here. It's got x squared, so I'm leaning towards B being the answer here. So I'm expecting it kind of to have this kind of a shape to it. In fact, when you do, I think we've done a little bit of rational functions. If you do rational functions, I expect this graph to look like this. Let's graph in our calculator, see what it actually looks like. So 2 over x squared. Oh, so it does look like that. In the right, on the left, it actually looks like this. I forgot it squared, so it's not going to have that look. But on the right quadrant there, it does have this kind of a look to it. So B is curved. Pretty tough question. I would expect you maybe to think through and eliminate C and D. Hopefully, A and B are tougher choices, but it does not look linear. So I might choose that one. That's it for today's lesson.